What's up, HVAC fam? Welcome back to the channel, Easy HVAC. Hope you're all having a great day. So in today's video, I just wanted to take the time to show you how to do a quick heating PM. Summer is officially over, so we will be entering the fall and winter months here pretty soon. Cooler temperatures, so we're going into heating season. So it's just good to know what to look for and what to check on the heating section of your HVAC unit. And I'm going to show you how to do this on a newer Lennox unit with a newer Prodigy board or Prodigy controller. Alright, so there's the Lennox Prodigy control, the newer Lennox Prodigy control. So we're just going to go through, or I'm going to take you through the process. It is still actually pretty warm today, so I'm not going to leave the unit in heat for too long. But just again, I want to show you the process and what to check and what to look out for and things like that. So I'm gonna open this up. All right. So the heating section on these models is at the bottom. We have 2 heat exchangers, 2 inducer motors, 2 gas valves, 2 manifolds. So we have 2 heating circuits. All right. So there's your inducer motor with your capacitor here. There's the gas valve. I believe this is a 2-stage gas valve. This is your flame sensor. I'm sorry, flame rollout switch. This is your flame rollout switch. And over here, you can see that rod right there. That is the flame sensor. All right, that's the flame sensor. And right here, I don't know if you can see that. But this thick wire right here, it goes into the burner section. That's your spark or your igniter. Your spark or your igniter. That's what ignites the gas as it's flowing through the manifold. And it's exactly the same on the other side. Your pressure switches are right here. These are the pressure switches. This is one. You have another one. Where is it? Let's see, I'm trying to find the other one. There it is. It's all the way in the corner. You can see it right there. All right, so that's pretty much the heating section, or those are the components. Now up here at the top, you have your 2 relays. Ice cube relays for your inducer motors. So whenever you get a call for heating, 24 volts energizes the coil, and then the contacts close and you have high voltage being sent to your inducer motors. So when you're doing a heating PM, what you want to do, things that you want to do is, first off, is to make sure that your the heating section or compartment is clean. So over the winter time, obviously, over the summertime, obviously you're not utilizing heat. So what happens is you get a lot of dust buildup and spider webs, cobwebs. It just gets really dirty. So if you have a brush of some sort, it's always a good idea to kind of just dust everything down. So I'm gonna get my brush here. Yeah, so take your brush, clear out all of the spider webs, all of the dust, the debris, Also, in this particular location, I don't know why, but the types of spiders that are in these units that spin these webs are actually black widows. So yeah, I've actually seen a couple of them. I haven't in a while, but for some reason there's a lot of them out here. So, you know, just if you're in an area kind of close to a bunch of trees or a wooded area, just be careful or be cautious of that, because that would suck to get bit by that type of spider. Wouldn't be too good. But no, I mean, they're pretty I mean, they typically just run away whenever you're messing around or messing with the unit, but yeah, just something to look out for. But yeah, just go ahead and give it a good cleaning, a good dusting. If you have a blower, like a little mini blower, that also works too. I mean, you can just take that and just you know, just blow out the compartment, dust off the inducer motor. And you can do the same for the other side. Just get it nice and clean. All right, so that's one thing you can do. Also, obviously, check all of your wire connections. Make sure everything is nice and tight. Nothing is loose. Take a look at the capacitors, because sometimes they will be super rusted. This is a newer model, or I mean, this is a newer unit, so everything in is relatively new. But in older units, I mean, you may have like super rusted capacitors. Just, I mean, things like, you know, things that you obviously want to check. But this capacitor doesn't look bloated or anything like that. Connections are tight. So, but yeah, you can check your capacitors, check your wire connections, check the pressure switch connections. Make sure your connections are good, tight, and nothing is corroded or anything like that. Check the condition of your hoses going to, right here, the condition of your hoses going to your pressure switches. So the inducer motor basically pulls a vacuum through the heat exchanger and also through the pressure switch. So the pressure switch is there to make sure, or to prove, that the inducer motor is running like it should. Okay, so you actually have a vacuum being pulled through this hose, right? You have a vacuum being pulled all the way to that pressure switch, and that pressure switch is rated for a particular value of inches of water column. I don't know what these are rated for, but I mean, you can look on the actual switch itself and see the rating. But they are rated for, you know, a certain value, and once that value is achieved, the pressure switch will close. Right? So they're normally open, but once the vacuum is pulled, the pressure switch will close. Again, to prove that the inducer motor is working like it should, and the control board sees that, and it continues with the cycle. And the next thing that happens is the igniter. You have your spark. Your igniter or your spark comes on, gas valve opens up, it's energized by 24 volts, gas flows through the manifold, and the gas is ignited. All right, so yes, check your hose, make sure it's not torn or ripped, or there are any tears along the way. Also, what you can do is you can actually take this off, take this hose off, and take like a piece of wire, skinny wire, or something small and skinny, and stick it in the hole, because sometimes the hole can get plugged up, and that can prevent you from, or that can prevent the switch from closing. All right, another thing is to look at the flame sensor itself. So that is the flame sensor. Okay, and you have one wire going to the flame sensor. The flame sensor basically proves a flame. It proves a flame, or proves that there is a flame, via a process called flame rectification. All right, so you'll notice that there's only one wire going to the flame sensor, and whereas typically in air conditioning, you know, you have two wires, right, going to contactors and relays. There's always typically two wires, one in, one out. But the flame sensor only has one wire, and the reason being is because the flame itself actually conducts electricity. Okay, so you actually have current moving through the flame. All right, and the circuit is completed via ground. All right, via the heat exchanger, or the either the heat exchanger or the burner side. But the current that is moving through the flame is like a pulsating DC current. Okay, pulsating DC current that the control board reads, and that's how it knows that there is a flame. All right, so that's in some, you know, basic. That's just a basic kind of breakdown. But that is flame rectification. So the flame itself is conducting, or is carrying current, right? Which is pretty cool. But check the porcelain. You'll see there's the porcelain there. Make sure it's not cracked or anything. Also, flame sensors, the rods can get carbon buildup. So the way, just because the rods themselves can get carbon buildup just because of you know, being exposed to constant flame. So you can actually clean that rod with a Brillo pad or some type of abrasive cloth, or if you have a $1 bill, that works too. But I would avoid using sandpaper, just because you can gouge out the actual rod itself. All right, but there's the, again, that's the flame sensor. Also check the wiring here, make sure it's tight. And you can also check flame sensors while the whole system is running via DC microamps. All right, so again, the flame is carrying current, although it doesn't conduct electricity very well. It doesn't carry the current very well, so the amp draw is extremely small. And it's so small it's in microamps, but that's how we can measure, or that's how we can check the flame sensor. And I'll make another video showing how to do that, but you essentially just connect your meter in series with the flame sensor, and then, you know, you set your meter to DC microamps, and you can check it that way. But yeah, that's just a breakdown. Obviously too, when you're doing a heating PM, check the belt, because you still need the blower to run to move the air. So this belt is nice and tight. I don't see any cracks. The belt is in pretty good shape. All right, so let's turn the unit on. And from the control board, we will test heat, just so that you can see the sequence of operations. So on these new controllers, anytime you want to put the unit in test mode, you go to main menu. Alright, click main menu. You are going to scroll down to service, select test. Test. Okay, you can test cool, you can test heat, you can test blower, damper, fans, everything. Pretty cool. I actually really like this controller just because it's so simple to put, or it's so simple to test what you need to test. So you come down here to heat, select heat. All right, we have 2 stages. All right, so I'm gonna select heat. And the first thing that should happen is the inducer motors should kick on. There we go. Inducer motors are on. Both of them, they sound good. They don't sound like the bearings are shot. Alright, now we wait for a flame. Wait for the pressure switches to close, for the board to pick that up, and for us to, and then for the spark. And there's our flame. Flame on both sides. So I'm gonna go ahead and turn it off just because it's still warm and I don't want the space to heat up. But yeah, that's pretty much the process. It's very simple. Flame rollout switches. Their job is to, as the name suggests, is to detect a flame rollout. And typically you may have a flame rollout whenever there may be a crack in the heat exchanger, and at that point you're pulling air through the heat exchanger and it's kind of forcing the flame out, right? So the flame is pulled in through the inducer motor. The inducer motor pulls the flame in, but when you have cracks in your heat exchanger again, that flame could be forced out, and when that happens, the rollout switch basically heats up because of the flame, and it opens and breaks the circuit, and it shuts the heating. It shuts everything off. So the flame rollout switch heats up because of the flame, and it opens the circuit. So it's there for safety. And flame rollouts are pretty obvious. I mean, the flame is literally like coming out. So that's how you know, or that's a good indicator that you have a bad heat exchanger if you don't check the heat exchanger. You know, if you don't check the heat exchanger before you turn the heating section on, that'll be a good indication that you do have a bad heat exchanger. So yeah, pretty straightforward. There's really nothing to it. The heating section is pretty easy. Like I said, I will make another video explaining how to check DC microamps for the flame sensor. And yeah, so like I said, pretty simple. But I wanted to share that with you guys just because, again, we're getting into the cooler months. So, I mean, I know it's still hot, but it's always good to just brush up, you know, on the heating section, because you go through, or you know, you go so long without really checking the heat because you don't need heat, right? So you can it can be easy to forget the steps and the processes. But yeah, guys, thanks for watching. I appreciate it. I appreciate all of your support and all of your comments. Feel free to leave comments. Let me know. I mean, let me know what you guys think. You know, if I'm doing anything, if I do something wrong, or if I explain something wrong, you know, please let me know. I don't know everything. I'm not a super tech in any way. And in this industry, you will never learn, or you will never know everything in this industry. So you're always learning. In this channel, my channel is a place for, you know, all of us, new techs, old techs, those that don't know HVAC. It's a place for all of us to come together and to learn and to share information. So again, I appreciate you guys for watching. If you like the channel, if you like the videos, please don't forget to subscribe, hit the notification bell, and so that you can stay up to date on all future videos. All right, guys, we'll see you on the next one.